This Torah class is brought to you by TorahAnytime.com.
Welcome everybody, welcome all our Torah Anytime viewers. We are on part 4. Wow, we're on part 4 already. Part 4 on the series on proving God. This class, I was conflicted on if I should put it in the proving God section or in the Torah section, because really what we're really focusing on today is two conflicting opinions. We have, or seemingly conflicting opinions. We have the scientific world that's telling us the Earth is 4.5 billion years old. We have the universe is 13.8 billion years old. And we have Torah give us sort of a number of 5,778 years old. So those numbers are not a little off. They're off by a lot. Like just add a bunch of zeros after it. That's how much we're talking about. So really this could have been, like Torah versus science. This could have been, so many different categories. One of the reasons I put it over here is because we dealt with the Big Bang. We dealt with a lot of, of that issues, and I feel like it's very closely related. And so I want to put it as close as I can possibly together. So generally when you have to have a conversation, when you're speaking to somebody who doesn't believe in God, very rarely, out of all the things, evolution, Big Bang, all these things come up very often. For some reason, the age of the universe, the age of the world doesn't come up as often as I would think that it would. Yeah, but every so often it does come up. And it's very, very interesting because this is more complex than more of the things that we spoke about. We're going to try to simplify and make it very simple and very easy to understand. But there are, when someone tells me, the world is 15 billion years old, and Torah says the world is only, less than 6,000 years old. So, Torah can't be true. So one of the first questions that I usually ask in this situation, I'm like, wow, that's so interesting. Can you please explain to me how they got to that conclusion of 15 billion years old? He's like, well, science says it. He's like, I got that part. But how? Like, what was the theories? What was the methods? How did they get to that? So most of the time, and it's 100% of the people that I spoke to, but I'm sure like a majority of people don't actually read upon it. They don't actually know about all the theories and methods and how the scientific theory got. So they usually tell me, whatever, the science says it. So I'm like, okay, fine. So then you have science in one corner, and you have Torah in another corner. Science is telling you one thing, but you don't know what science is actually saying. A scientist is telling you that. Then you have Torah in another corner. You don't really know what the Torah is saying. A rabbi is telling you what the Torah is saying. Did you actually go and do the calculation and know that it's 5,778 years old? No. You just assumed it because that's the year that we are right now, and we trust whatever, the rabbis that are coming. So what you're really doing, it's not science and the Torah, it's a scientist versus the rabbi, is where you're doing so you believe him versus somebody else. So generally at that point in time, they get very confused. It's a very confused look on the face. But science says it, and the Torah, it's just like mumble grumbles. So what I want to actually go on, the way that we're going to go and discuss this class, and by the way, this class, whoever's not aware of, is we're going to be speaking about the age of the universe and the age of the earth. Two separate numbers and two separate things that we're going to try to plug in together from the Torah perspective. So the way that we're going to do it is it's always good to understand the other side. If you want to refute somebody, you have to know where they're coming from. You can't just go on a one-side argument. So I'm going to give you a lot of information that is where science bases off their information, how old the universe is, how old the earth is. So we're going to start off with the age of the universe. The age of the universe, according to science, as of January 2018, and I'm saying January 2018 because science always changing, even though they're 99.1% accurate in their understanding that's how accurate they are. But we're still going to say January 2018. The universe is 13.8 billion years old. How did they get to that? So we're going to give you three different ways that they get to this number. Number one is the idea that if something is in the universe is old, the universe has to be older than that. So if you find something that's really, really old in the universe has to be at least that age. Make sense? So what they really do is they look at the age of the stars. And if you're able to find the age of the stars, the way that they're able to decide the age of the stars is based on its mass, and it's also based on its brightness. And based off that, they're able to go and figure out how long the star has been around. So if they find a star that's 13 billion years old, they say at least the universe has to be at least 13 billion years old. That's method number one. Method number two is based off expansion. We spoke about in the first class in the series of the Big Bang, we spoke about that according to science, the universe is expanding. So if the universe is expanding, if we reverse that, and we bring it back to the center, we would be able to figure out when that all came. If we have the constant, if we know how long it took for the universe to expand, if we minus that, we'll be able to get to when it's all started. So think of it this way. Think of it, you have a sniper that, shot somebody in a building. And the detectives, what they do is based at the point of entry of the bullet, they're able to sort of go back, trace it to where the sniper was in the building. That where was he that he pointed a sniper, and where did he shoot it? So think of it something like that. We're sort of reversing the psychology of where the world came, where it is now, based on the factors that we have to where it came into the beginning. So assuming that everything is constant, that the universe is extending at a constant rate, we would have come to roughly about 10 billion years old in science world. However, according to the science, they know that it wasn't constant. So what they do is they put in the variables of the change. Sometimes it was slower. In the beginning, it was a little bit slower. Now it's a little bit faster. So they put that all in, and they get roughly about 13.7 billion years old. So again, that's another method of figuring out how old the universe is. The other way is through the travel of light. So this is something very interesting. The speed of light, which we're going to speak about pretty heavily today, B'ezrat Hashem, the speed of light is a very, 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 very fast. In fact, there's nothing in the world, in the universe, that goes faster than the speed of light. The speed of light is 186,282 miles per second. Let's just, for easy to understand it, we're going to call it 186,000 miles per second. To understand that, if you were to want to get from here to Azerbaijan in a speed of light, it would take you less than a second. How much less than a second? If you would travel the speed of light, in 1 second, you could go around the world 7.5 times. That's how fast the speed of light is. So, in space is very large. And because it's so large, it could actually take time for the light to come. So we know the sun is 93 million miles away. When you're looking at the sun, you're not looking at it right now. The sun, the time that it takes for the light from the sun to reach us is 8 minutes and 20 seconds. Which means when you're looking at the sun, you're looking at it 8 minutes and 20 seconds ago. It's not there anymore. If you want to shoot the sun, you would have to factor that in, 8 minutes and 20 seconds ago. That's where it was, so where is it going to be now? The same idea. The nearest star is 4.3 light years away. So when you're seeing a star right now, the closest star to the world, you're seeing it how it was 4.3 years ago. Think of it, when you look at the sky, you're looking at a time machine. You're not looking at it what's it right now. You're looking how it was. Could be thousands, could be millions, it could be even billions years ago. And this is where they say the nearest galaxy is the Andromeda galaxy, and that is 2.3 million light years away. That's very, very far. And by the way, this is very, very interesting, because on a clear night, if you know where you're looking at, you could actually see this galaxy with your naked eye from the Earth. You could actually look at the Earth, and you could see another galaxy. It looks like a little bit of a dust. If you take a small, a camera or a telescope, you'll be able to actually zoom in into that, and you actually see the dust particles and the way that the galaxy looks. It's a very large galaxy. It has twice as many stars as our galaxy, but you're able to see it. Which means according to science, if this galaxy is 2.3 million light years away, that means that the universe has to exist at least 2.3 million years, because we see it from the Earth, which means the light, it took it for travel 2.3 million years. So hence, the galaxy is at least 2.3 million years. Now, in the scientific world, we're able to see stars that were created billions years ago. So hence, the universe is, according to science, billions of years old. Clear? So far, very simple. Now, what I found very interesting, NASA has a website, and its website has a very interesting webpage that it says the age and size of the universe throughout the years. We don't care about the size, we're going to be focusing on the years. Things change over time. Science has more information, and things change. So let's go through a little travel through the journey of time of science, of where and how old the universe was. In 1919, they considered the universe to be infinite. Now, granted, there's different ideas of it, but the majority of the scientific world thought that the universe existed forever. It always was and always will be. This is what we spoke about in class number 1, called the static universe, always will stay. 1929, after Hubble came around, the universe came out with a number, the scientific world came out with a number that the universe is 2 billion years old. Very big difference between infinite to 2 billion years old. Okay, Baruch Hashem, we're progressing. 1955, it went to 6 billion years old. In 1965, it went to between 10 to 25 billion years old. In 1993, it moved to 12 to 20 billion years. And in 2006, we got to the current age, which is now, is 13.7 billion years old. So we see there was a little bit of change going through time. So the question that I have And I'm sure some of you would have, okay, so now you're telling me it's 13.7 billion years old, but what's going to be in 10 years? What's going to be in 20 years? Maybe they're going to find something else, and they're going to say, oh, we were wrong all along. It's actually X, Y, and Z. So just because science says something, science is known to be constantly changing, constantly evolving. So who says that this is the most accurate number that we can have? Maybe there is a constant, maybe there is a variable that comes into play all of a sudden that completely ruins everything that we discussed. That is the age of the universe. Let's focus on now the age of the Earth. The age of the Earth, according to science now, is 4.5 billion years old. In the 1700s, it was believed there was actually a wide range of belief in the 1700s. But from a section of the scientific world, the age of the Earth ranged anywhere from 75,000 years to several billion years. Now, when the second night I read that, I was like, that's like someone going to the store and be like, "Excuse me, how much is this?" I'd be like, "It's anywhere from 1 cent to $100 million." Okay, thank you. How much is this? Anywhere from 1 cent to $100 million. That's not really giving me any information. That's just telling me just like a number out in the blue. But regardless, there's one thing that scientific world did say is that the world existed for more than 6,000 years. That's the important factor that we want to take out. This is in the 1700s. In the year 1862, there was a person by the name of Kelvin, Lord Kelvin. This was not his rapper name. His name was actually William Thomson, who was actually, he came out with the Kelvin scale. So he came out with the estimate age of the Earth in 1862. He came out that it's 98 million years old. And he based it on a model of the rate of the cooling of the Earth. The Earth was initially very hot, and it cooled over time. And he based his number over the cooling, so it says 98 million years old. A short while later, in 1897, he revised it. He made an announcement. He says, "Listen, I take back my old number. It was incorrect. The correct age of the universe, of the world, is between 20 to 40 million years old." So we revised it. If you were to ask anybody, in 1897, how old is the Earth, they would tell you with full confidence it's between 20 to 40 million years old. That's just 100 years ago. 100 years ago, tell you with full confidence that is. Then science comes up and says, well, he didn't know about radioactivity, and the heating of the Earth's crust is by radioactive decay, and all other nice bits and pieces of information from science world. They say he didn't know this, and hence that's why he was wrong. So, but they were very, very confident in the number. So what I ask is, they're very, very confident in the number today. But who says, just like they were confident back then, who says that it's not going to change again? Now, back then they were confident. Today they're also confident. Is it possible that it's going to change? It's definitely possible. So now let's figure out how they dated the Earth. How did they date the Earth? So if you go to a tree, and if you want to know how old the tree is, you first kill it, and then you can tell how old it is. How are you going to tell how old it is? You see by its rings. You see by the rings of the, and it's actually very interesting because when there is, when the tree grew a lot, there's a lot of rain, let's say it was able to grow a lot, the rings are fatter. And when the tree was not able to grow a lot, the rings were thinner. And they're able to sort of double check this information based on the historical records they have of the weather. And they see if it makes sense that year where that tree was it very little rain? And they're able to actually see that. So you're able to date things based off the rings. Now, this is not only off live trees. They're able to actually do this off dead trees as well. What they do is if, let's say, they find a live tree and a dead tree. They look at the dead tree, they look at its rings, and they look at the live tree and they look at its rings. Now, if, let's say, they could find, let's say, a few hundred, or let's say 200, because trees live a very long time. You have trees that live thousands of years. If you have, let's say, 200 years of this tree matches up with 200 years of the rings of this tree, then you could overlap them and you could go back in time to see how old the Earth was. And this could come back, according to science, over 10,000 years old. So which means there's something was going on here already 10,000 years ago. There's another way in using the similar method is based off ice layers. So the ice layers, every year in really, really cold places, there more ice falls in. Now, it doesn't melt because it's really, really cold, so it builds up. When they drill really deep down, they're able to say, okay, this was one ice layer, and this is the next ice layer. And they're able to go down, and according to science, in these layers, there are some things that could be hundreds of thousands of years old, which means that these ice layers were there for hundreds of thousands of years, according to this method. That is one method of dating the Earth. There's another method called radiometric dating. This is very, very popular nowadays, and I do want to spend time in understanding this. Now, if you're allergic to chemistry, it's fine. But I will have to indulge a little bit in chemistry in order for you to understand it. I find it very interesting, very fascinating, but for everybody else, it's, just bear with me. So, there's something called a periodic table. Right now, everyone's like, in the Never 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 land. Oh man, talking about periodic table. Yeah, I'm talking about periodic table. So, there is elements in the periodic table. And we're going to use the element of carbon. Carbon, there is, before we even get to that, every atom has a nucleus. In the nucleus is the center. Think of it as a center. This is where you have protons and neutrons. And around it is flying, somebody? Electrons. Very good. Okay. Baruch Hashem. So you have protons and neutrons in the center, electrons flying around in the outer. Now, a mass number is the number of protons plus the number of neutrons. So if I were to tell you a certain element of carbon has 6 protons and 6 neutrons, you would know that the mass number is 12. Very good. Oh, excellent. You guys are good. Okay. So, right. So, a certain atom, right? A certain atom, you realize that I'm only asking you questions on chemistry, because it doesn't matter if you don't know it or not. Torah, I don't ask questions, because that you have to know. So a certain atom will always have the same number of protons. However, neutrons could be different. Now, these elements could come in different flavors. Think of it different flavors. We call it isotopes. But it could come out in different flavors. An example is, let's use carbon. Carbon is always going to have 6 protons. But if it has 6 neutrons, so this we call carbon-12. If, let's say, another carbon has 6 protons and 8 neutrons, we'll call this carbon, this is hard, 14. Oh, very good. Wow, excellent. Carbon-14 has 6 protons and 8 neutrons. So these atoms of the same element with different neutrons, we call them isotopes. Some isotopes are radioactive. Bear with me, it's almost over. Okay? Some atoms are, I might not be saying the full truth, it's almost over. Some isotopes are something called radioactive. Radioactive is something very interesting. Radioactive means that they're unstable. Not emotionally unstable. They are, maybe you could call them emotionally unstable. The nucleus is, right, the nucleus is unstable. So what it does is it tries to stabilize itself. Now, how does it stabilize itself? What it does is it decays. Now, it decays doesn't mean it rots and it disappears. It shoots off protons and neutrons until it stabilizes itself. Now, we call this radiation. When it's shooting off protons and neutrons, this is called radiation. It could be alpha, beta. We don't have to get into it. It's irrelevant. But what happens is when it shoots off these protons and neutrons, it changes what it is. It's able to morph what it is. Now, it could either change itself to the same atom, the same element, but of a different isotope, or it could change itself to a completely different element. Okay, that's what you have to know about that. Now, carbon dating. Are you familiar with carbon dating? I'm sure you've heard of it. The way that carbon dating works is the carbon dating only works with radioactive isotopes, things that are unstable. Things that are unstable, they change over time. Now, if you know how long it takes for something to change, you'll be able to calculate how much time it took for it to change. So this is something we use this called a half-life. Carbon-14 has a half-life of 5,730 years. We're going to use to simplify, we're going to say 5,700 years.
Is that also radioactive decay?
Yes, radioactive decay, same thing. So the half-life of this carbon-14 is 5,700 years. To understand this, let me simplify it. Let's say you have 100 atoms, and I tell you the half-life is 30 minutes. Now, if you have this 100 atoms on a plate, you're going to come back 30 minutes later, you're only going to have 50 atoms. You're going to come back an hour later, you're only going to have 25 atoms, because every time that there's a half-life, half of it goes away. Where it goes, we'll get to it in a minute, but it goes away. So if I tell you that there was 100 atoms on this plate, and you come back and you see only 25, and if I were to ask you, how long ago did I put these atoms on this plate, you would be able to say, based off that, 1 hour ago. Because every 30 minutes, half of it goes away. So the first 30 minutes, 50 it went away. The next 30 minutes, 25 went away. This is how they do something called carbon dating. Carbon dating, so they have carbon-14 has a half-life of 5,730 years. So every 5,730 years, half of that carbon-14 is gone. Where does it go? It changes to nitrogen-14. Irrelevant, but it's not carbon-14 anymore. Now, if you know the original amount of carbon-14 of this certain fossil, and you know how much it is right now, you'd be able to see how long this fossil was around for. Make sense? That is something called carbon dating. People argue on carbon dating why it's not so accurate. One of the main reasons why it's not accurate, it happens to be it's pretty accurate. One of the reasons why it's not accurate is because it can get contaminated. If it's contaminated, you ruin the whole thing. The whole, whatever, thanks to all our, pollution and bombs, it does ruin a little bit the system, but nevertheless it still works. However, we can only date, being that a half-life is pretty short, 5,700, and you can't go and date, billions of years with this because eventually it's going to disappear. So we could only basically date for this for about 50,000 years. So what the scientists do is they don't look at the half-life of carbon, they look at the half-life of things that have a very, very large half-life. For an example, potassium-40. Potassium-40 has a very long half-life. Eventually it's going to decay to argon-40. How long? 1.3 billion years. So if you see a rock, for example, that has half potassium-40 and half argon-40, you know that this rock has been around for 1.3 billion years old. Good so far? Right, but half-life, but half of it has decayed. You go by the half. So that is the way going through, that is the idea of going through radiometric dating. This is very interesting because there's a lot of factors that we don't need to get into it. There's some things that, there are erosion factors. There are other ideas that, things change over time. They go into different places. So they have answers for this. Also in the science world, they use, for example, zirconium grains, which don't erode over time. Or they take meteorites that come from outer space, and they date those, which means they didn't have the same issues that they have on Earth. And they all come roughly to about 4.4 billion years old. So here we see, from this method, that the world, and what they do is when they date the universe, they say the whole solar system, I'm sorry, not the universe, the whole solar system came into being at the same time. So if they're able to date something of a meteorite that came from outer space, they say the world came to exist in the same amount of time. So this is where they get the number about 4.5 billion years old. Clear? I think that was very simple. Right? I think that was very simple. Okay, so now at least you learned something. Nonsense. It's all nonsense and Nauschkeit and whatever. But this is the science, and we got to respect their opinions. Nowadays you have to validate everyone. You have to validate my opinion. All right, we're validating their opinion. Now let's argue on it. Now, the first step of argument is we're going to argue from the scientific world. Not all scientists believe that the world was existed for so long. And if they do, they have some problems with it. One of these people is Dr. Gentry, Dr. Robert Gentry. Now, this Dr. Robert Gentry, he went and he studied hundreds of thousands of rocks. Now, what he did is that he looked at something called polonium-218. Now, this is something very interesting because he looked at the halos of polonium-18, and these are produced through radioactive decay. Similar to the whole thing that we spoke about until now. If you didn't understand anything I said, just make believe, nod your head, and let's move forward in life. Okay, it's not going to be that important, but it's good to understand these facts. So, the problem over here rises like this. He has a rock that has a halo of polonium-218. The problem with polonium-218 is it has a very, very short half-life. The half-life is 3 minutes, which means is that when this rock formed, it had to form very, very quickly in order for the halos to exist on the rock. Now, this is a very, very big contradiction according to our current science, because according to science, we know that the Earth originally was a bunch of like it was lava everywhere. It was a very, very hot place scientifically. We're speaking very strictly scientifically right now. The world was a very, very hot place. We're talking about over 1,000 degrees Celsius. Everything was like molten lava everywhere. And then eventually, over time, the Earth cooled. Eventually, the Earth cooled. According to science, it went into the Ice Age. It went and it cooled. This cooling period took millions and millions of years, according to science. Now, if it took millions and millions of years, how come we see the halos that could only been produced in 3 minutes or less? So we see something here. So there's something very, very wrong here. To understand this is why I went and I purchased Alka-Seltzer. This is why we started this thing. So if I take this Alka-Seltzer, and as you see, I'm putting it into the water, you're going to see it bubble up. And if I would want to capture all these bubbles, I have, and this is what we did before the class, this is why I timed it. It took about 2 minutes, a little bit over 2 minutes for the bubbles to stop bubbling. So which means is if I would want to freeze this cup of water right here in my hand, with the Alka-Seltzer still bubbling, I have less than 2 minutes to freeze it. Because then and you freeze it, you still see the bubbles. Eventually, it would rest, like that one over there, and the bubbles are only sticking to the plastic over there. So you wouldn't see it. So I have less than 2 minutes to freeze it. And if I freeze it more than 2 minutes, you're not going to see any bubbles on here. This is what it's dealing with in the rock. This is what I paid for it to, this is all I needed for it. If anybody needs Alka-Seltzer, enjoy it. But, so here you see something very interesting. You have these rocks that have these halos of polonium-218. Now, in order for it to exist, it had to cool and solidify very, very quickly. Not like what science say that it took millions and millions of years, which means is there's something wrong over here. There's something fishy going on over here. There's something that's not so constant that we think is so constant. Dr. Gentry compared it to something like this, and him and his son did this research, that imagine you have this cup of water right over here, and it's dripping at a solid drip, 1 drip per second inside this water. You walk into the room and you see this volume of water dripping in at 1 drip per second. Now, if you know how much the drip is going per second, you would be able to calculate how long ago the water faucet was left on and how much it went in, right? Good gateway to drink. So, if you would be able to calculate it. Now, what happens if, let's say, I walk in and it's starting to drip? It's like halfway through the drip, it's like halfway the cup is filled to where you see it, and I decide I need to wash my hands. And I turn the faucet on full hand, I wash my hands, and I close it, and it's still dripping at the same exact drip factor. Now, when you go and you do your whole calculation, because you're a scientist, right? You put your glasses and you have your pocket protector, you're a full scientist, right? You go, you build a spaceship, you go, you have your whiteboard, you calculate all your stuff, and it comes out exactly the number. Now, is that number accurate? Absolutely not. Why? Because I opened the faucet, and now you introduce so much different variables into it that it's impossible to know it. So this is how Dr. Gentry explained it. He says like this. He says that the way that the Earth was before is not necessarily the way that the Earth is right now, which means is that your radiometric dating is not going to be accurate, because if I was able to see this halos within 3 minutes, who knows what else was going on? Things are not the way that they are right now. And this is going to lead us to the Torah portion. Baruch Hashem, we got to the Torah portion of this shiur. The Rabbi and Dr. Akiva Tatz, I want to share with you something that he says. He's a medical doctor, and he gave a great example on this. He said like this. He says that you can't assess a mathematical system while the rules of mathematics is being formed. You have to wait till something is formed until you're going to be able to assess a system. And here is a very, very clear and easy example. When you look at the person, a human being, imagine you know how the human being body works, an adult, only an adult. You know exactly how the human body, everything, all the physiological, all the aspects of the human body, you know exactly how it works. Would you be able to judge what happens to a fetus by just having knowledge of an adult? Absolutely not. You could try, but you will make extreme radical errors. Why? Because it's completely different. A fetus doesn't breathe. It doesn't go through its mouth. The lungs don't function. They get feeding through a different tube. They don't eat through their mouth. Everything is completely different. The blood flows differently than it does when it's alive. So the way the system of formation is completely different than the system that comes out. Here's another example. You look at an adult at the age of 20. Would you be able to guesstimate around how that adult will look when they were 15? Yeah, roughly. Pick a little, change the little features. You'd be able to figure it out. Would you, just by looking at an adult, be able to figure out how this adult looked 6 months into pregnancy? Absolutely not. You have no clue. You have no clue, because it's a completely different system. When it's in the mother's womb, it works completely different when it's outside the mother's womb. You are not able to judge what's happening inside based only on the information that you have when it comes outside. The same idea, this is a Nobel Prize winner, Paul Dirac, says like this. At the beginning of time, the laws of nature were probably very different from what they are now. So that means that things are not constant. If things are not constant, then you cannot accurately describe what happened in the beginning of time, which is what we're trying to do right over here. Think of it this way. Say you have this phone, and let's use actually an easier example, a watch. You go to a watch and you open up the watch. You'll be able to figure out, okay, he probably put this piece before this piece and this piece after this piece. If you know a little bit about how the watch works, you'll be able to, sort of like take it apart and build it again from scratch, from where it is. But if I were to ask you, take out this watch and tell me where he laid all those pieces on the table. So you have this piece was laid over here. It's impossible to know such a thing. Why? Because you don't know. It's different. It's a different system. The same idea is what we're talking about the universe. There was a different system in the beginning of the universe. How can you go and figure out what's happening right now based off a system that you don't know what happened in the formation? Is this clear? This has to be very, very clear. Is this clear? This is sweet. This is so sweet. It's such a in the face, if I may say, but this, we don't know. It really is, we don't know. This is just like saying the factor of opening up the faucet. You don't know the drip rate factor. You don't know how long it was dripping because you don't know what happened in the interim. Now let's look in the beginning of history. Is there something in the beginning of history that ruined our constant, that ruined our ability to say, yes, everything happened since the beginning of a time exactly the same? And yes, we can. We can say two things were changed. Number one is the first 6 days of creation. The first 6 days of creation, we don't know how it was. Nature was not like it was today. How can you say that? First of all, when was the sun created? the fourth, day number 4. When were the trees created? Day number 3. Can trees be alive without the sun? How does that work? Must be that there was a different system. The laws of nature were a little bit different, or a lot different, we don't know, back then. There's another factor that we have to put into the play, is the Mabul, the flood. The flood completely changed everything. In fact, there was an opinion, and I wish I remember this. So when I was learning about the flood, I don't even think I spoke about this when I spoke about the hidden story of the flood. But one of the ways that one of the Mefarshim that speaks about it says that how did Hashem bring about all this flood? He actually moved the stars from the constellation. So the gravitational pull, everything was changed around, which means is that nature in itself was completely changed. And we know the Mabul brings down some fascinating facts that the world before the Mabul is radically different than the world after the Mabul. And when we see something very interesting, that when Noach came out of the Teva, did he see bones everywhere? Where were the bones?
Right?
Where did they go? How did they get to the ground?
God.
God is a good answer, yeah. Some people say it was boiling, some must have, but not necessarily. The Mabul says something very interesting. Where did the water go? So what Hashem did, Hashem opened up the cavities of the earth, and He put all the water down. Now when this water went down to the cavities of the earth, it also dragged down all the bones. You have these large animals that existed before the flood that didn't make it on the Teva. These all large animals went under the earth. Now there's something very interesting when they look at fossils. They're talking about the rock stratification, the rock strata, the levels of the rock, the lower it is. There's something very interesting. This I think we spoke about in one of the classes. If you're baking a 7-layer cake, the first layer goes before the first, and then the second, and then the third, and then the fourth, right? That's how you see. So if I were to go and I would say, what was put here first? The first layer, the second layer, or the third layer? You would say the first layer came in first, the second layer came first. But I could say that I baked, or whatever, I don't know how you say creation in baking term. I made the first layer, second layer, third layer, and then what I did was I lifted everything up and I slid in another layer. Can I do that? Of course I can do that. I don't know, I don't bake. So, you could technically slide it in. How did the dinosaurs or all these other fossils, how did they get so far into the ground, so far into the rock strata levels? Very interesting. Someone placed it there. The water brought it all the way down and put it all the way down in those deep levels of if you want to call it rock or whatever it is that into the ground. So just because something is deeper or lower in the level of the rock stratification does not necessarily mean it's older if something went down there. The Sephorah says something very interesting in the Parashat Noach. Why does the world have seasons? We have fall, winter, spring. In New York, whatever. We have, sometimes in the winter we have summer and spring inside, and sometimes in the summer, whatever. It's a bipolar situation. But, generally we have seasons. Why do we have seasons? There's something very interesting. The Earth does not spin straight on its axis. It spins on a tilt. And because it spins on a tilt, it's actually 23.5 degrees on a tilt. And because on a tilt, we have these changes in weather. The Mabul says something very interesting that and by the way, you should know that in, let's say, for example, like the coldest place, the North Pole. The North Pole was at one point much hotter because the whole world tilted. It was much hotter, and according to science, this is actually proven. They have they say 55 million years ago, the North Pole was a nice chilling 74 degrees. 74 degrees in the North Pole. So it was like Miami weather in the North Pole. What happened was, I don't know how the science worlds claim the differentiation of the difference of how ice cool age or whatever the cooling of the Earth across whatever it is that they use it for. The Earth was tilted and it was changed. Now, the Mabul says like this. It says the world was turned northward, which means is that every bone that you find in the north actually used to be south of the equator. It was not actually where it is, and it's very interesting because they find these animals that cannot live in very cold places, in fossils of these cold places. Now, how it's possible? Because it used to be warmer. Now, the Mabul brings down, the Earth was tilted. It was tilted. When it was tilted, there was a downgrade in air quality. You know how amazing it was? Back then, it says before the flood, when we spoke about the hidden story of the flood, we said it used to rain once in every 40 years. Now, there's many questions that you could ask in that, but I don't know. The spoilage, how is it possible to rain once in every 40 years? The answer is it was a completely different world. How did people live for thousands of years, hundreds of years? Not thousands of years, hundreds of years, because it was a completely different world. The world, something very interesting. The world was not on a tilt before the Mabul. The Earth was on a straight axis. It was spinning straight on its axis. Only afterwards, after the Mabul, it was produced on a tilt. So beforehand, the world was completely different. And if the world is completely different, we just introduce a variable that's not constant anymore in this calculation that you're making. Which means is that based on your calculations of 13.8 billion years old, it might not be accurate. Why might it not be accurate? Because it's very likely that the Earth changed, and we know we have our sources in Torah speak about that. So that is answer number one. We got to one answer at least, Baruch Hashem, so far. That is that the laws that which you have right now are not necessarily constant, which makes all the scientific findings not necessarily accurate. Let's go to the second answer. When Adam was born. Was Adam born as a baby, as a teenager, going through his teenage phase, and be like, no, come on, I want to sofa, I want to drive, Was he born in that? Was he born in an adult phase? What phase was Adam created in? And he was created in a mature adult phase. The trees were fully grown when Adam, in the first day of creation. Now, granted, you say it was a little bit, and then it grew up. Whatever. The point being is, when Adam was in Gan Eden, when Adam was in the world, everything was fully grown. There is, at night, Adam was able to look at the stars, and he would see the stars. The question is, how could he see the stars if they were just created 3 days ago? It has to be 2 million light years away. How could he see the stars? There's another factor. There's some animal, there's some insects that they live off decay matter. If they were just created, where would the decay matter come from? So which must mean something very, very interesting. Just like Adam was created in a mature state, the world could have also been created in a mature state. Can you say right now that the world was created, you were created 5 minutes ago, and you were brought with all your previous memories, and you're brought right now? Can you say that can you, we have the Torah that says that the world was around for a long time, the 6 days of creation, so we can't say it, but assume, put in the Torah aside. If I were to tell you, you were created 5 minutes ago, all your memories are put inside in it, and the first thing was in this class. That's when you just popped in this class with the whole thing. It's gonna start to be like, wait a minute, was I? And I've had these conversations with people. I've sat once with somebody, and then suddenly I'm like talking to him, and then he just like drops his decibel, his the voice level like really low, and I spoke to him like in a very low whisper. I'm like, why are we whispering? He's like, because they're listening. I'm like, who's listening? He's like, the FBI. I'm like, why is the FBI listening to you, and what do I need to know? And he's like, well, they're always listening to me. Did you take your medication today is my next question. Generally, or do you have a tin hat made out of foil that I could wear also? People have the, things that are going on through their mind. Not to judge him, chas v'shalom, because to each own. Maybe the FBI was listening to this guy who doesn't have a job and is listening. It's very, very possible. I wouldn't see why not. But it's very interesting because you don't know that. We know that based off the Torah, but you don't know that you weren't created right now with all your memories. But we know something very interesting, that if Adam, the trees, everything else in creation was created in a mature state, what is to say that the world was not created in a mature state? You know what? You'll come to the conclusion the world is 15 billion years old. There's something, they make genes now. For the life of me, I can't understand this. Or this is the genius of marketing. You come to the store, I'd like to buy new jeans. But please make my jeans look like they've been worn for about the past 1,000 years. I want rips in them. I want to see that it's faded. I want to see that it's So they can create jeans look like they were faded. They can create stuff that looks like it was really, really old. Just like they can create this, don't you think that God maybe could have created the world as if it was 15 billion years old? And that's a completely logical explanation for it. It's very possible the world, you come into saying that the world is an expansion, it's going that, yeah, you're right. You're really right. Yeah, it looks like it's like that because that's how God created it. A very simple answer, beautiful answer. I love it. It's one of my favorite ones. We're going to go through the other ones. So the Dr. Gerald Schroeder, brought a beautiful, so beautiful. I'm going to really summarize a lot of his information, but if you really want to look into you really have to look inside, his speeches. He has books written about this. So to begin, we have to speak about something everybody here, I'm sure, loves, is Einstein's laws of relativity. Or by who? It's not.
It was. They proved it wrong.
Einstein's theory of relativity, as far as I know, is not proven false. It's actually proven accurate with our GPS system works on that. So yeah. So if it was, please send it to me. I'm very very happy to hear it. The Einstein, if you're from, his law of relativity is like this. It's something very interesting. I'm going to tell you things right now. If you've never heard of the laws of relativity, this is going to sound completely like impossible. But bear with me. This was actually proven. He says like this: time is affected by your view of time. If you are, and it depends on a few, and actually two big variables. if you would, let's say, on Earth, a minute goes a certain speed. If you are on the moon, the minute would go faster. If you are on the sun, the time would go slower. And in fact, there's something that depends on time. If you have a place that is increasing gravity, time is going to go slower. Time is not always the same. Time changes. It's something so fascinating, so interesting. If you increase your speed, time also goes slower. Now let's explain this relativity. Now, this is a very nice example if you like these brain teasers. There's a truck. There's a flatbed truck. You're able to see into this truck. And it's a very, very long truck, an 18-wheeler. And you have two people standing on the truck, and they're playing catch on this truck. This truck is traveling at 50 miles per hour. These two people are playing catch. They're throwing the ball at 10 miles per hour. How fast is the ball going? Dun, 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 dun. So the answer is, it depends where you're looking at it from. It's relative. Beautiful. It's relative. How is it relative? If you have a radar gun and you're sitting on the truck and you check the speed of the ball, it's going to look at 10 miles per hour. If you are off the truck and you're looking at the speed of the ball, it's going to come at 60 miles per hour. 50 miles per hour of the truck plus the 10 miles per hour of the ball is going to come into 60 miles per hour, which means is that things are relative to each other. This is something very interesting. When you're standing on the ground, are you standing still? Well, in relative to what? Not really, because the Earth is moving, and the galaxies are moving, the sun is moving, everything is constantly moving. So when you're judging something, you're only judging something in relative to something else. Which means is that nothing is in absolute rest and nothing is in absolute motion. Things move in relativity to each other. Cool so far? Fascinating, beautiful. So there's something called space-time continuum. Not to bore you, we know that there's up, down, right, left, all around. No, different song. Up, down, right, left, forward, and back. That is the three time dimensions. There's also a fourth time dimension called the space-time dimension, which is how the observation of space and time differ based on how you're observing it. Now, to explain it like this, I'm going to simplify it. I'm trying to make it as simple as possible. By the way, the way that this was proven is that they took atomic clocks, and if we have time, I have to explain to you how clocks work. It's really fascinating how the whole science behind these things work. They took these atomic clocks and they put it on airplanes, on fast airplanes, and they each set them exactly to the second, and they send them around the world. When they came back, they were all completely different. Because depending on the speed, depending on where they were, the time changes a little bit. It changes. And this is proven. This was all accurate according to Einstein's theory of relativity. The way that we have our GPS locations right now is all thanks to Einstein's theory of relativity, because they all have to factor in these things. There's something called the twin paradox. Fascinating thing. You have two 5-year-old twins. You have one twin that you put on a spaceship that travels 99.9% the speed of light. Right, impossible nowadays, but let's just theoretically say that this twin travels at 99.9% the speed of light. And it travels at 99.9% the speed of light for 5 years. It comes back 5 years later. How old is this twin if it was 5 years when it left? 5 years old, right? Now it's 10 years old. 5 years plus 5 years is 10 years old. Good? See a lot of blank faces. It's pretty simple. 5 plus 5. Okay. So the twin was 5 years old. He got on a spaceship, traveled for 5 years in 99.9% the speed of light, which is very, very fast. Came back. He's 10 years old right now. How old is his other twin? His twin that left is now 110 years old. Because when he's traveling the speed of light, and this is how you could think of time travel. Time travel technically is possible in the future if you could travel really, really fast. Because if you travel really, really fast, time slows down. And if we have time afterwards, I could actually prove it to you how it actually works. It's really fascinating. I don't want to spend too much time on this. But if you travel really, really fast, time slows down. So this twin, which travels for 5 years at 99.9% of the speed of light, grew and aged 5 years. His twin grew and aged 105 years. So his twin is now 110 years old, and he is 5 years old. Things are always irrelevant of each other, and time changes. But one thing that doesn't change is the speed of light. The speed of light is always constant. So if I were to tell you, how many years has it been since this kid left the earth? Has it been 5 years, or has it been 105 years? And if you were to tell me 5 years, you're right. And if you were to tell me 105 years, you're also right. Because it all depends on where you are observing it, where you're looking at this. So this is something very interesting. When you're telling me that the Earth is 13.8 billion years old, and where are you looking at it from? Are you looking at it from your earthly, space-time continuum? Then yeah, it makes sense. Which means this is something very interesting, that when the scientists tell you that the Earth is 13.8 billion years old, they're right. But there's one thing that they're missing telling you, that this time is based from the time-space coordinates that we exist on Earth. But what happens if you look at time from a different place? And then there's billions of places around the universe where time goes completely different. If you have a huge, huge planet, time goes much slower. Is it possible that 6 days on Earth would equal 13 billion years on another planet? And the answer is yes, because time and space is different in all aspects of it. So when I am saying 6 days old is the creation, and you're telling me it's 13 billion years old, can we both be correct? The answer is yes, we can both be correct. Does this make sense?
That's Alka-Seltzer.
Thank you for that. So, I said, is this correct? And you told me that's Alka-Seltzer. It threw me off for a second. Okay, now let's go to something a little bit different. Light travels at 186,000 miles per second. If you are going to the beginning of time, and you were to shoot a pulse of light, and you were to put information on this pulse of light, this is called fiber optics, you were to put information on this pulse of light saying that I am sending this pulse of light every second. So every second you shoot another pulse of light in the beginning of time. And you're on Earth, and you receive this pulse of light, and you're like, hey look, a pulse of light. You decipher the code, and it says, hey, I'm sending you a pulse of light every second. Now the question is, when are you going to get the next pulse of light? Is it going to be in the next second? Not necessarily, because we know the universe is expanding. Which means is if the universe is expanding greater than the speed of light, so that now the distance between those two pulses are going to be greatly differentiated by a great amount of time. Now how long is that going to take you to get there? I don't know, depending on how long the universe expanded. Since that beam of light was sent, that's how long it's going to take. Clear so far? Okay. There was something very interesting. In cosmology, the question is, how was the beginning of time? How was time? Let's rephrase that. How was time in the beginning of time different than what we have time now? Was it different? Maybe the beginning of time was different than what we have right now. And they came out with an answer. It was different. How different was it? It was a million of a million times different, which means is that if you have 1 second over here, a million is a trillion. So if you have 1 second over here, that's a trillion seconds. So for example, if you shoot that beam of light in the first second, let's say the first, how long is the next second going to come? It's not going to come in the next second, it's going to come in the next trillion seconds. Because that's the differentiation of time from the beginning to the time that we are right now. Clear? Okay, good. Now, let's plug in this math. We said that there are 6 days of creation. The 6th day Adam was created. So if we were to take the 6 days of creation, was it 6 days in our time? Not necessarily. How much was it? 6 trillion days. Right? Because everything was times a trillion of where we are versus the time that we have now versus the time that we have then. This is Dr. Schroeder's all calculations. Beautiful. So if you take 6 days and you turn it into 6 trillion days, you divide it by 365, you get a very interesting number. You get a number close to where we have over here. What is it? About 15 or 16 billion years old. So which means is the 16 billion years can be that 6 days if you're looking at it from where right now, the difference of the time. Now I decided to do something, this is my own little thing, let's change it. We know Adam was created on the 6th day. What happens if you do the first 5 days? So if you take the first 5 days, and it's not really first 5 days according to time because we have to times everything by a trillion. So you take 5 days, you make it turns it into really trillion days because 5 trillion days from where it really is now, from our observation nowadays. If you take 5 trillion days and you divide it by 365 and a quarter, with 365 let's say, you get to 13.6 billion years old. Roughly, that's very, very close to where we're dealing with right now in science saying 13.8 billion years old of the creation. This is fascinating. This is beautiful. Isn't this beautiful? Everything just works in so nicely. Okay, let me give you one more answer. It says in Tehillim, chapter 90, verse 4, it says, Ki elef shanim be'enecha ki yom etmol. God's one day counts as human years, 1,000 years. How to explain it? We don't have time, nor it's sort of irrelevant for this perspective. Just trust me on that. One day of God is 1,000 years of human years. Ki elef shanim be'enecha ki yom etmol. So now, if you have something like this, here's by the way, very interesting proof. Adam, when God says to Adam, if the day then from you eat from the tree, That day you will die. But we know Adam lived for much more than a tree. He lived a little bit under 1,000 years. How is it possible if God said that you're going to die in the day that you eat from the tree, and God, Adam, died only 960 years later, 930 years later? I'm sorry. So where did all the, that doesn't make any sense. So we have different explanations, but there's a very interesting explanation, because God says you're going to die in that day. Whose day we're referring to? Referring to God's day. God's day is 1,000 years. Did he die under 1,000? He did die under 1,000 years. So it says that you're going to die in that day. He did die in that day. A day where who said that we're referring to the human days, we're actually referring to God days. So let's speak about something called from the Sefer HaTmuna. Sefer HaTmuna, this is from Rabbi Aryeh Kaplan. Brought in beautifully how he explains this, beautifully. So he says something like this. The Sefer HaTmuna was brought down, is a tribute to Rabbi Nechuna ben Akana. This is between the 1st and 2nd century, when he was alive. He was at the same time as Rabbi Yochanan ben Zakkai. He also is attributed to the authorship of the Bahir, as well as, the prayer Ana B'Koach is attributed to him. So Rabbi Nechuna ben Akana. So it says like this. He wrote a sefer called Sefer HaTmuna. And in it, he deals the idea of Shemitah. Shemitah, we know that every 6 years you work the field, and the 7th year is a sabbatical year, you don't touch the field. He says just like there are 6 years of the field and 7 years you don't touch it, the same thing works in the world. There are 6,000 years of the world, and then the 7th year is the Shemitah year. You don't touch it. Now, which means it's like that's like the Mashiach period. However, we know there's something called Yovel. Yovel is there are 7 cycles of the Shemitah cycles. So the Shemitah is 7 years times 7 cycles of that is 49 years. He says just like there is a Shemitah cycle and a Yovel cycle in the world, there's also a Shemitah cycle and a Yovel cycle of the universe, of the entire creation. So he says that the universe is to exist not for just 6,000 years, but rather for 49,000 years, a complete Yovel cycle. Now the question is, where are we right now? In which section of the Shemitah, in which section of the Yovel are we right now? So Rabbi Yitzchak de Mina brings in the following calculation. He says that, by the way, he was a Talmud of the Ramban. He was a very, very big Kabbalist. Very interesting thing. If maybe we could speak about him, about the authorship of the Zohar, Moshe de Leon. Maybe we'll speak about it, later if we have time. He says something very, very interesting like this. He says that which Shemitah cycle are we in? The 7th. So that means we already existed for 42,000 years. It's already in existence, right? 7 times 6, right? We got that? 42 times 1,000, 7,000 years. But is this human years we're referring to, or is this God years? And he says, no, we're not referring to human years, the Yovel cycle of 49,000 years, but rather we're referring to God years, which means you have to do a very, very simple calculation. And it is, if 1 day of God is 1,000 years of human life, so then you take 1 year of human, times it by 365 and a quarter, because that's how many days there are in a year, times 1,000, and that would equal 1 of God year. So 1 God year would equal 365 to 250,000 years. Yeah, right. 365, 250. That's 1 God year is 365,250 years. Now we have to times that by 42,000 years, because that's how much is in existence. So if you take 42,000 times 365 and 250,000, I gave wrong information, we get into a very interesting number, 15.3 billion years old. He says, according to this example, it makes perfectly sense that it's roughly what we're talking about in the world, that it is 15.3 billion years old, very close to the age that we have of the universe right now. Okay, so here we see something very interesting. So we see that it's very likely, from the Torah perspective, that the universe and the Torah, the scientific world and the Torah are not contradicting each other. It depends how you look at it. We brought many different, ideas in it. We brought, number one, it's very possible that the world is, created in a mature state. We also brought in different ideas on how the world, according to the Torah, actually could be that many years old. We also brought an idea that not necessarily everything that you see in science is actually legitimate. They're always constantly changing it. We also brought in the fact that there are things that are not constant, which actually relates to the previous one. There are things that are constantly changing. We brought the Mabul, we brought the time of the creation, we brought Robert Gentry also as a proof that if things are not constantly in the same method that they were beforehand, then this brings into question, how accurate are your results. There is something very interesting that I do want to share with you. We spoke about Rabbi Yitzchak min Akko. There's a lot of stuff that I skipped over here that I wanted to speak about, but this one part I thought was very interesting. Who was this Rabbi Yitzchak min Akko? He was a Talmud of the Ramban, and he was considered a very, very great Kabbalist. He's actually quoted in the Reshit Chochmah. Reshit Chochmah is very famously known for some people as, if you want to learn about Gehenom, about hell, he speaks a lot about the Reshit Chochmah. There's no translation that have been in English as far as the Reshit Chochmah. It's the same name. It's not. As far as I know, they don't have a translation in English, especially not the section that speaks about Gehenom. But Rabbi Yaron Reuven made a class about Gehenom. You can listen to it if you want. Rabbi Yaron Reuven. I do at one point want to speak about that topic, but we'll leave it for now. But in any case, so this Rabbi Yitzchak min Akko, he brought in the he quote you ever the Zohar? Say how much I have to give information. So you guys know the Zohar, right? So there was a question who wrote the Zohar. It was a question to the authenticity, to the authorship, actually, not to the authenticity, to the authorship of the Zohar. There's some people that say that it was written by Rabbi Moshe de Leon. Now, because he brought it in, he was the one who published it. Now So this Rabbi Yitzchak min Akko, he actually did the research to find out. He was friends with Moshe de Leon, and he went to find out what was the story with it. And then his whole research is actually written in Sefer HaYuchsin. And right before he finishes concluding with who wrote the authorship of the Zohar, it just finishes. He doesn't have any information in there anymore. So historians, looking through history, they say, well, we don't know who wrote the authorship of the Zohar because he never finished off the research that he was doing. However, Rabbi Aryeh Kaplan brings down. He says he got a hold of a manuscript that was written by Rabbi Yitzchak min Akko. It was brought to him to be translated. There's only one of them that is left in the world. I mean, there's obviously copies now, but there's one original, and he went and he translated. And in that manuscript, which is known as the Otzar HaChaim, he is written down that the authorship of the Zohar is 100% Rabbi Shimon Bar Yochai. Undeniable. So here, you have people that are not sure. It is known, 100% that the authorship of the Zohar, and this is Rabbi Yitzchak min Akko, which we said that he's referring to the 42,000 years of the world was there, times ago. What? Otzar HaChaim. And it's Otzar HaChaim. So I found it very, very interesting, a little bit interesting tidbit of information. So we have over here that, generally when people come and they ask questions about God, and they ask questions about religion, about conflicting between Torah and science, usually, and I say usually, they don't know science and they don't know Torah. Because if they know both, there would not be any conflicting with it. It's something very interesting, because when you get educated on both aspects of it, you see more times than not, they're not conflicting with each other. Sometimes, evolution, we spoke about it, about that time, there's conflicting ideas on evolution that is very, very against the Torah. But all in all, the more that you learn about these things, the more everything looks in common, the more everything looks in sync, the more everything looks that there is a purpose and a plan in creation, that everything is and comes from up above. And I find that this series is extremely, extremely important, because even if you believe in God, it's always good to solidify everything. It's always good to solidify the idea that 100% that everything is this. And we're just getting started over here. We're going to get into the Torah, we're going to get into other topics that we're going to speak about, that it's really going to solidify your idea that not only are going to be for you, but also can be able to go and B'ezrat Hashem hopefully convince other people as well. Any questions? Yeah.
I'm confused. Are you confirming that science is true?
I am not confirming nor denying, but I'm saying it can work in the Torah.
So it's possible.
It's possible.
It is billions of years old?
Not necessarily that it's billion, but based off our technology and our way we have it, we see it as billions of years old, and it could be that way.
So then what's the 5, 7, 7, 8 from?
Oh, excellent. I can't believe I forgot to say that. 5 sevens, that is from when do we start counting? From Adam HaRishon. We count that from Adam HaRishon, which means we don't count that. Yeah? No, we start counting from Adam HaRishon, so it's 5,778 years from Adam HaRishon, which means plus, from when it was created, plus the 5 days, plus those 5 days.
For when he was born.
No, but same idea. Yeah. But does it make sense? So it's 5,778 plus those 5 days. How are those 5 days? That's what we went through a different idea. And even if we went through before the creation, because we're talking about Adam HaRishon, not the 5 days at the beginning of the creation. That's the time that we're referring to right now.
So the answer is both.
The answer can be both. I like being very vague. No, but the truth is it really can be both, because it can appear, it's not conflicting based off the things. I never said that the earth is 13 billion years old. But I said it can look like that. It's very possible to be that way. Is it possible that God created, that the 6 days of creation really lasted for really, really long periods of time? It's possible. Not very common opinions of all the commentators, but you could say that it's possible that the 5 days was not, the 6 days of creation was not actually 6 days that we have today. Because we said the only time that we count a lot of, let's say, a day is based off, for example, the sun. The sun wasn't created until day number 4. So where were the first 3 days? How do you calculate those days? So there's many different factors of it, but one thing's for sure is that they don't conflict with each other. The purpose of this class was to show you that they do not conflict with each other at all.
So you said the first 6 days of creation, the way the time goes, because it wasn't like a human day. You said there was 1,000 years or a trillion years?
So a trillion years. So there was 2 answers that we gave. So it's a trillion years. A trillion years is based off the time that we have now. How was it different from the beginning of time? And the answer is it was a trillion-fold different.
But if it's like God says on the first day of creation and on the second day, isn't that like 1,000 years apart?
Well, no, so it's very interesting because that's not what we're focusing on. We're focusing on not the days of God, so saying 6,000 days, but we're actually, that was a completely different calculation when we said about the gods of 1,000 days. We're focusing on, in that answer, we're focusing on how time looks from our perspective versus time looking from the beginning perspective, because we brought in Einstein's theory of relativity showing that time is different depending on how you look at it.
I have another question.
Yeah.
You said how in Noah's time, how all the bones went down into the earth, and like, you know how when they discovered a bunch of
fossils?
Yeah, and they made shapes of dinosaurs and stuff. Could it be possible that was the bones of the people? Because you said they were giants.
Well, with the bones that they have of the fossils of the dinosaurs actually look like animals, not like humans. So it is possible, but it's probably most likely. But you should also know that a lot of these fossils, they don't actually find a full fossil. They found, for example, a full fossil of a full white, of a mammoth. But dinosaurs, they sort of reconstruct it based off. They find a piece over here, find a piece over here, figure out the specifications based on the size of the skull, based on this, and they sort of put the picture together. You go to this Museum of Natural History. I don't think they found all those bones inside of there, and then you're looking at all those bones, from billions of years old. I may be incorrect in this. I didn't look into it, but the idea is that it is, it is bits and pieces, but it's very likely. We know Adam was very, very tall. How do we understand that? The whole world back then was completely different. There's so many proofs that I can give you from the Torah that the world was completely different. The people lived there longer. The people were extremely tall. They only got married. They only had children at the age of 100 plus. You're dealing with it completely different. Now if you're 28, you're old. 38, forget about it. It was a completely different world. It was a completely different world.
Where are those people's bones? Because I'm assuming there was a lot of people that died during the Mabul.
Yeah.
Where did their bones go?
Do they find all the fossils? Could be very possible. It's very deep down. It's also very possible that some of them disintegrated in the heat of the Mabul. It was very, very hot. We don't know everything that exists on the Earth. We have our fossil record is pretty solid, but do we have everything? No, we have a lot.
So when the Earth moved on its axis, other things moved, there are fossils found that it couldn't have existed in that climate. Fossils moved not only species that were alive at the time.
No, which means that the fossils moved. The fossils are represented by the species, so the species could have been really living in those places.
Right. Okay. Also, so then when would have the ice age occurred? Because if during the Mabul, every place was at one certain climate, so if you were at a climate where it was only cold... Ice
age did not happen before or after the Mabul. That we know. So, I'm pretty confident in that. Scientists say that it happened after the Earth's cooling. According to science, it's very interesting because the way that they say something very interesting. And again, this is disputed in the science world. How did the Earth come into being? There was a bunch of they did a very interesting study that they took salt particles and they put it into space and with zero gravity and in the spaceship, and the salt particles started combining together. So they built this into figuring out this is how's the Earth, a big mass, created. That originally there were a bunch of rocks and debris falling all over the galaxy, and they started combining. They started combining together, and as they got bigger, they got a mass. As they got a bigger mass, they got gravitational pull, and they got bigger and bigger and bigger, like a snowball effect, until eventually became what we know as the Earth. And at one point, it was was boiling lava, and there were like meteorites just like keep on flowing into the falling into the earth, and that's how it created where it is today. After this boiling mass eventually cooled off.
It cooled off to such an extent, like it was so hot, and then it just froze, and now it's getting warmer.
Yeah.
Doesn't make sense.
Now, if you look at it in the science, there is reasons for it.
I know.
We're not here to explain the science. We're here to explain the Torah part, so it's irrelevant of that.
According to the Torah, like.
According to the Torah, there's no mention of an ice age. But then again, we don't mention of it. But yeah, so what are the proof that they have of this ice age? I don't know. I didn't look into it.
It didn't happen at all.
I don't know. I have to look into it. I didn't look enough into the ice age to tell you. Any other questions? Go ahead. I see you have questions. No, it's good. People always love the questions. Unless you don't want to. I'm not going to force you. Any other questions on camera?
Yeah, fine.
Yeah.
The thing we said about the Big Bang with Einstein and Hubble, what was that theory that Einstein had? Because that may be what I'm confusing it with.
Einstein's he was teaching at one point the static universe.
Oh, I think that's what I was.
Yeah, it's not really relevant so much to what we have over here, but I'm saying
that they were able to prove false.
Yes, that's what they were able to prove false. Yeah. Okay, so it could be that's what you're doing. Any other questions on camera? Any other questions on camera? Shouldn't be bashful. People love the questions. I mean, that's what they tell me. I don't know. Maybe they're just saying that.
Yeah, but she's making fun of me.
They find the questions very interesting because some of them have the same questions as that. Good. Is it clear? I thought it was beautiful. No, isn't it fascinating?
Yeah.
It is fascinating. Okay.
Once I understood it.
Once you understood it, that's it. You can always review it. Okay. It's good. Chazak u'baruch. Okay.
You've just experienced another Torah class brought to you by TorahAnytime.com.